Hey fam, welcome to Driven Life Math and Physics. So today we're going to be continuing looking at Archimedes principle questions. So the first one here is a rectangular metal block of volume 0.015 cubic meters. Is completely immersed in a fluid. Now, once again, the completely immersed part is very important. That means the volume of the block should be equal to the volume of liquid displaced. Okay, so because this thing is completely immersed, so the fluid density is 1200. The metal has a volume of 0.015 cubic meters, and they're saying it is suspended from a spring balance, and the reading is what? 110 newtons. So what we're saying here is the volume of the metal block is equal to 0.015 cubic meters. Okay, and then the density of the fluid is equal to 1200 kgs per cubic meter. Okay, from there we also know that the weight of the block in the fluid is equal to 110 newtons. So the 110 newtons here is the weight that the spring balance shows when this thing is hanging but immersed fully in the liquid. Okay, so that is the weight when upthrust is acting on the object. All right, now, so what they're saying, we should calculate the weight of the block in air. How do we find the weight of the block in air? The thing that we can look at is when this thing is suspended, we know the volume. Okay, we know the weight of the block in the liquid when it is fully immersed in the liquid. We know the density of the fluid. And the only way we can do this is by using the equation that says weight of the object in air minus weight of the object in the fluid. Okay, so this weight of the object in the fluid is this one we've written here. We've said of the block in the fluid. That should give us what? Upthrust. So to find this, we need to know this, which is already given. Then we need to know upthrust. So first of all, let's find upthrust. Upthrust is equal to weight of liquid displaced, okay, or fluid displaced. So that will be equal to density of fluid multiplied by volume of fluid displaced times G, which is gravitational field strength. Okay, now from there, the density of the fluid is 1200 kgs per cubic meter multiplied by volume of the fluid displaced will be equal to the object's volume. Why? It was completely immersed. Okay, so that will be 0.015 cubic meters multiplied by the gravitational field strength 10 newtons per kg. Okay, so these things can cancel out. Now we need to make a calculation of that. Let me just open my calculator for me to find that value right here. So if you try to multiply all that, that is 1200 multiplied by 0.015 multiplied by 10. What you end up getting is 180 newtons. So that is the upthrust. Okay, that's the upthrust right there. Now to find the weight of the object in air, remember, so that will be equal to weight of the object in air will be equal to upthrust plus weight of the block in the fluid. So from there, it means it will be equal to 180 newtons. Okay, 180 newtons plus 110 newtons. Okay, so this one plus 110 newtons, you get 290 newtons. That's the weight of the block in air. That's what we found right here. Okay, now from there, they want us to find the upthrust, which I think you would just rewrite this because I've already calculated it. And then they want us to find the density of the block. Okay, so the density of the block, we know the block, the weight of the block in air. Weight of the block in air is equal to 290 newtons. Okay, and then we know the volume of the block, which is equal to 0.015 cubic meters. That means the density will be, we have to know the mass to find the density. But now, if weight in air is equal to that, that means we can calculate mass. So mass will be equal to weight divided by G. So what is the weight? 290 newtons divided by 10 newtons per kg. That is 29 kgs. Okay, so I found the mass. Once we find the mass, we can now calculate. We can now calculate the density. So density of the block is mass over volume. So the mass of the block is this one, which is 29 kgs, okay, divided by 0.015 cubic meters. Okay, so once we do the calculation there, we'll end up finding 29 divided by 0.015. That gives us a very, very big figure, which is 1933.33 kg per cubic meter. That should be our density of the metal block. Okay, so I want you to do this on your own, then verify if you actually find the right answer from there. But otherwise, this is all I had for you. Thank you so much. Catch you in the next one.